Welcome back to students. So today in this section I will be explaining the problems from the section final velocity after displacement. And this section in your textbook, it's on page number 54, and this is practice E. Okay, so it's on page number 54, practice E. I'll be start doing problems from question number 2 because question number 1 is a continuation of the sample question. So let me read question number 2. A car traveling initially at 7 meters per second accelerates uniformly at the rate of 0.80 meter per second square for a distance of 245 meters. And they're asking what is the velocity at the end of the acceleration. So you're looking for final velocity. Okay. And now we may look at the values given there. A car traveling initially at 7 meters per second. So the initial velocity of the car is given. So this is practice E, page 54. Okay. So in question number 2, the values given are VI, initial velocity of the car is given. That's equal to VI is equal to 7.0 plus 7.0. That means it's going in the positive direction. Okay. 7.0 meter per second. Accelerates uniformly at the rate of 0.80 meter per second square. So acceleration is given. A is equal to 0.80 meter per second square for a distance of 245 meters. So delta x, the distance traveled, is equal to 245 meters. In part A, they're asking you what is the velocity at the end of the acceleration. So you're looking for VF in part A. So you may now look at which equation you have to use. VI is given, A is given, delta x is given, and you're looking for VF. And if you look at on the equation set, you can see the last equation, VF square is equal to VI square plus 2A delta x. This equation you can use, okay? So the equation I'm going to use is VF square is equal to VI square plus 2A delta x. And you may think why I use that equation. If you look at other equations, third equation is having that time variable is there and time is not given. Okay. Second equation you cannot use because there is no delta x is there. Okay. First equation also you cannot use because time is not given. So our option is the fourth equation. Okay. So this is very simple. You just directly want to plug all the values. So your VF square is equal to VA square is 7.0 square plus 2 times the acceleration is 0.80 times your delta x is 245 meters. So VF square is going to be 7 square is 49. So 49 plus 2 times 0.80 times delta x is 245. So that is 441. So VF will be equal to square root of 441. That is equal to 21 meter per second. So this is the answer for part A. And in part B, they are asking what is the velocity after it accelerates for 125 meters. So you are using the same method. The only difference is delta x is, instead of 245, you are going to use what? Delta x as 125, okay? I will just do B. C you can do. This is same as part A, okay? So in B, VI is the same, okay? The car starts with what velocity? VI is the same, VI is equal to 7 meter per second. Acceleration also same, there's no change. A is equal to 0.80 meter per second square. And instead of 245, now in B part, the delta x is going to be how much? 125 meters. So now again, you can use the same equation. You are looking for Bf. What's our equation? Our equation is Vf square equal to Vi square plus 2a delta x. So that's going to be Vi square is 7.0 square plus 2 times 0.80 times delta x is 125, and this is going to be 249. So this is the value of Vf square. Okay, so Vf is going to be square root of 249. So it's 15.77. So your Vf is 15.77 meter per second. Now you may look at the number of significant figures. In the question, you have only least number of significant figures is 2, so you can round this to 16 meter per second. C is also same. In C, you can see in C part, they are asking what is the velocity after it accelerates for 67 meters. So in this case, you just want to change that delta x as what? 67 meters. Okay. Now I will do question number 3. One second, please. In question number 3, a car accelerates uniformly in a straight line from rest at the rate of 2.3 meter per second square. So from rest means your Vi is going to be 0 because it starts from rest. So Vi is equal to 0 meter per second. At the rate of, it accelerates at the rate of 2.3 meter per second square. So your acceleration is 2.3 meter per second square. And in A part, they're asking, in part A of the question, they're asking, what's the speed of the car after it has traveled 55 meters? So again, it's the same story, okay? Like you're looking for Vf. Okay, so the same equation you're going to use, Vf square is equal to Vi square plus 2a delta x. So that is equal to, what's the value of Vi square here? Vi square is 0. Okay, so simply this, since Vi is 0, the equation simply reduced to this one. Vf square is equal to 2a delta x. Okay, so since Vi is 0, your equation reduces to Vf square is equal to 2a delta x. Okay, so now you may plug the values. So that is equal to 2 times a is equal to how much? A is 2.3 meter per second square times delta x is how much? Delta x is, what's the speed of the car after it has traveled 55 meters. So your delta x is 55 meters. So this times 55. So that's going to be 2 times 2.3 times 55. That is 253. So this is the value of Vf square. So Vf is going to be square root of 253. So that is 15.90. That's equal to 15.9 meter per second. Since in this question the least number of significant figure is 2, you can round this to 16 meter per second. So this is the answer for part A. And part B, they're asking how long does it take for the car to travel 55 meters. So now they're asking how long. So they're asking for the time. Okay. So in part B, they're asking for time, delta t. You're looking for delta t, how long. Okay, they're asking how long does it take the car to travel 55 meters. So delta x is the same, 55. Okay, and what was your vi? Vi is 0. Everything is the same. Okay, um, vi equal to 0. And vf, just now you calculated. Okay, just now you calculated what was the value of vf from part A. Vf is 16 meter per second. Okay, this value we calculated from where? In part A we calculated vf. Okay, the final velocity of the car after just travel is 55 meters. Now you have vi, vf, delta t. Okay, and also acceleration also given there. What's the acceleration? 2.3 meter per second square. That's also given there, okay, in the question. So the easy equation is, you may look at, see, if you look at the second equation, Vf is equal to Vi plus A delta t. So that is the easy equation for solving this one, okay. Vf is equal to, the equation is Vf is equal to Vi plus A delta t, because you are looking for time. And since you start from rest, your VA is 0. So this equation will reduce to VF is equal to, since VA is 0, this equation reduces to VF is equal to A delta T. And you are looking for time. So delta T will be VF divided by A. What's your VF? We already calculated 16 meter per second. Divided by what's your acceleration? 2.3 meter per second square. So 16 divided by 2.3, that's going to be 6.95. So that you can round to. So that is delta t is equal to 6.95 seconds. So in two significant figures, this will be 7.0 seconds. Okay. So this is the answer for 3B. Now, I'll do question number 4. In question number 4, a motorboat accelerates uniformly from a velocity of 6.5 meter per second to the west. So its direction is going to the west. Okay, so your VI is 6.5 meter per second west, or you can write, since it is going to the west, it is minus 6.5 meter per second. So this is your VI. Why it's minus? Because the motorboat is going to the west. Okay, and accelerates uniformly from a velocity of 6.5 meter per second to the west to a velocity of 1.5 meter per second to the west. So his velocity reduced. The final velocity is 1.5 meter per second west, or you can say minus 1.5 meter per second. Again, I'm telling why is minus because it's going to the west. So your VI is minus 6.5 and your VF is minus 1.5 meter per second. And what else is given there? If its acceleration was 2.7 meter per second to the east, so the value of acceleration is 2.7 meter per second square east. Or simply you can say plus 2.7. Why? It's acting towards east. And you know, if velocity and acceleration acts in the opposite direction, the object slows down. Here you can see the object is going to the west, so velocity is acting towards west and the acceleration is towards east. That's why it's slowing down. Final velocity is less than the initial velocity. How far did the car did it travel during the acceleration? So how far means you are looking for delta x. So this is the unknown value. You have to find out this one, delta x. Okay, it's question mark. So again, you may check which equation you can use. Here, VI is given, VF is given, A is given. You are looking for delta x, no time. Okay, so the equation you are going to use is the fourth equation. The equation is VF square equal to VI square plus 2A delta x. So since we are looking for this delta x, okay, just keep this term on the right hand side and bring VI to the VI square to the left hand side. So this equation I can rearrange like this. So VF square minus VI square equal to 2A delta x. So you are looking for delta x. So this bring this 2 and A to the left hand side. So it will be like this. VF square minus VI square, the whole divided by 2A equal to delta x. So now you just want to plug in the values, okay? So equation I am writing here, VF square minus VI square divided by 2A equal to delta x. So what was your VF? Your VF was minus 1.5 and VA is minus 6.5. So that is minus 1.5 square minus VA is 6.5 square divided by 2 times, what was the value of A? A is 2.7 plus 2.7 meter per second square. This is the value of delta x. And now minus 1.5 square, it will become plus, okay? So 1.5 square is 2.25. So this is 2.25 minus 6.5 square is 42.25 divided by 2 times 2.7 is 5.4. So this is the value of delta x. So just solve it. 2.25 minus 42.25 divided by 5.4. So your final answer is minus 7.4. So the value of delta x is equal to minus 7.4 meters. Why it's minus? Because the object was moving to the west. Okay, but in this question they are asking how far. So they are not asking the displacement, they are just asking the distance. So there's no need to put the minus sign. So the magnitude of that one is simply 7.4 meters. Okay. So now I'll do question number 5. In question number 5, let me read the question. An aircraft has a lift-off speed of 33 meters per second. What minimum constant acceleration does this require if the aircraft is to be airborne after the takeoff run of 240 meters? So this is like aircraft, it's on the runway. It's going to start, okay, like it's going to start. So when it starts from rest. So VI of the aircraft is how much? That's not given the question, but you know, the runway is going to start from rest. VI is 0. And it's given it has a lift-off speed 33 meters per second. Lift-off speed means the speed when it is about to leave the ground. Okay, that means the time at which the speed at which the aircraft is airborne. Okay, like from the ground, it's just airborne. Okay, so what's that speed? The lift-off speed is 33 meters per second. So your VF is 33 meters per second. So when the aircraft reaches this speed 33 meters per second, it will become much airborne. So for that, what's the distance traveled by that aircraft? All of a sudden it won't reach that velocity. It has to travel a certain distance. You know, through the runway the aircraft is just going really fast. Okay, so that distance delta x, distance traveled during this time, is how much? Delta x is 240 meter. And they're asking, for this to occur, what minimum constant acceleration does this require? So you're looking for the acceleration of the aircraft. It's a very simple question, direct question. So you're going to use the last equation, Vf square equal to Vi square plus 2a delta x. Here Vi is 0, so this equation will reduce to, since Vi is 0, this equation will reduce to Vf square is equal to 2a delta x. We are looking for a, so a is going to be acceleration is Vf square divided by 2 delta x. So that is equal to, what is your Vf value? 33 square, 33 meter per second square divided by 2 times delta x is how much? 240 meter. So your acceleration is going to be 33 square divided by 2 times 240. So that is 2.26. Okay. So since there is only two significant figure, you can round this to 2.3 meter per second square. So this is the acceleration of the aircraft, 2.3 meter per second square. And now the last question. Question number 6. A certain car is capable of accelerating at a uniform rate of 0.85 meter per second square. So the acceleration is given there. Acceleration of the car is 0.85 meter per second square. What is the magnitude of the car's displacement? So you are looking for delta x as it accelerates uniformly from a speed of 83 kilometers per hour to one of 94 kilometers per hour. So you can see you're looking for delta x. Put a question mark. And what's the magnitude of car's displacement as it accelerates uniformly from a speed of 83 kilometers per hour. So what's your Vi? Is 83 kilometers per hour. But you have to get one thing. Acceleration is given in meter per second square. The time is in seconds. And distance also in meters. Meters per second square. Acceleration is given in meters per second square. And the velocity is given in kilometers per hour. So you need to convert this kilometer per hour to meter per second. And you know, if you want to convert this kilometer per hour to meter per second, you need to multiply this kilometer per hour with what? 5/18. Then you will get the answer in meter per second. Okay, so this 83 kilometer per hour is going to be 83 times 5 over 18, that is equal to 23.05. So you can round this to 23 meters per second. So your VI is 83 kilometer per hour, that is same as 23 meters per second. And your VF, what's the value of VF? VF is 94 kilometers per hour. 94 kilometers per hour, and that is going to be um, 94 times 5 over 18, that's equal to 26.1. So you can simply write 26 meters per seconds. So now you got the value of VI and VF. It's 23 meter per second and 26 meter per second. And what they're asking for, you're looking for delta x. Okay, so you are which equation you are going to use? The fourth equation you are going to use. So let's write the equation. Bf square equal to pi square plus 2a delta x. Since you are looking for delta x, you can bring the vi square to the left hand side, the same step we did before. So vf square minus vi square is equal to 2a delta x. So your delta x will be equal to, displacement is equal to vf square minus vi square divided by 2a, that is equal to, what was the value of vf? Vf is 26 meter per second. So 26 meter per second square minus, what was the value of vi? 23 meter per second. So 23 meter per second square divided by 2 times acceleration. What was the value of acceleration given the question? Acceleration is 0.85 meter per second square. 0.85 meter per second square. So this is going to be 26 square minus 23 square, that is 147, divided by 2 times 0.85, that is 1.7. So when you solve this, 147 divided by 1.7 is going to be 86.47. So simply you can write, this is 86.45. In two significant figures, it's simply 86. Okay. Once again, let me check. 26 square minus 23 square divided by 2 times. What was the acceleration given there? 0.85. Yeah, 86.47. So you can round this to 86 meters. So that's all this section. Thank you very much.